let's go on and get started. Because I think we finished finding the, no, we did not. Huh?
We did because we ran out of time.
That's it, yep. Because for some reason I thought we got out of here at 49, not 40. So this is as far as we got, and I think the last thing I was saying was that we do need to be careful with theta, the angle value, because it's going to depend on the quadrant that it's in. Now, for the most part, if it's in the wrong quadrant, I believe we're just going to be able to add theta or add pi to it, or add 180 degrees to it to get to the other side. Yes. Yeah, we're going to be able to add pi to it to fix the angle if it's in the wrong quadrant. So if we look at, well, I'll let y'all pick. Do we want to look at 32 or 33? 32. So here, the first thing we need to find is the value of r. Well, r is a squared plus b squared. So our a value in this case is -6. Our b value in this case is square root of 2 squared. Now for this here, I would definitely plug it into the 30xs, mainly because it will reduce radicals if it's not a perfect square. Which is a good thing we did that, because r is the square root of 38. Now we found half of what we need. The next part we need to find is theta. Well, theta is equal to b over a. Square root of 2 over -6. So in this here, it's already in radians, so I can say second tangent inverse of the square root of 2 over -6. Which is this here. We can try to see if we can convert it to a fractional form, but that is it. Now, if we get an ugly decimal, I'm going to switch it from radians to degrees. Okay. This is a little bit nicer than our radian measure, so I'm going to go with it -13.26, -13.3. Now, if we do this in radians and we end up in the wrong quadrant, we add pi to it, or 360, or 2 pi. Pi if we need to go to the opposite side, from fourth to second, or first to third. And if we just need to go back to the fourth quadrant, we're going to add 2 pi to get back to the correct angle. Now, for degrees, we're going to do a similar thing, but instead of pi, it's 180. Instead of 2 pi, it's 360. Now to determine this, well, I'm going to draw a little quadrant plane for us, and we can figure out where we're at. Because we have a negative x, positive y, so we're over in the second quadrant. Negative a, positive b, second quadrant. Our angle is down here in the fourth. So if we were dealing with radians, we would add pi to it. Since we're dealing with degrees, we would add 180. And luckily, we already have it in the calculator, so I just have to hit plus 180 and get this here. So 166.73, we can say 166.7. So we added 180 to it to get our angle of 166.7. 7 degrees. Questions on how we found r and theta? So our final answer is the square root of 38 parentheses cosine of 166.7 degrees plus I sine of 166.7 degrees. And that's it. And if you pick radians or degrees, either one I will take. If it's not the one that I have listed down, I will double check it and see if that is the correct radian measure. So, questions on these two here before we look at the next ones. Write the complex number in rectangular form. We're just multiplying back out. Do be careful to make sure the calculator's in the correct form. We'll look at 35 because the calculator's already in degrees. Because all we're going to do is multiply square root of 48 by cosine of 120 and square root of 48 by sine of 120. So second square root 48 cosine of 120 degrees. Negative 2 square root of 3. Second square root 48 sine 120. 6 plus 6 I. Because we do have to add the I back in, and that's it. Questions on this here? Evaluate in standard trig form. We're multiplying. Because when we multiply two trigonometric numbers in this form here, it's our R1 times R2 times cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. Multiply the R values together and then add the angles. So here we're multiplying 3/4 by our 4. Cosine, we're adding these two angles together. Well, out of all this here, there's one thing I know for sure we can do without a calculator, and that's our 3/4 times 4, which is 3. So we'd multiply the 3 and 4 is 12. 12 divided by 4 is 3, and we get this here. The second part is going to be pi over 3 plus 3 pi over 4? Yes. Adding these two together to give us 13 pi over 12. And we get this here. Evaluate in standard and trig form. Yeah. Questions on this here? Let's see what the heck is meaning by that. 36. Okay. Oh, okay. So we have this form here. All it means by and in standard form is, well, 3 cosine of it's like, why is it not working? Oh. I just didn't have it in the correct form. So negative 3 square root of 6 minus 3 square root of 2 over 4. Then we do the same for sine. Negative 3 square root of 6 plus square root of 2. the other iteration of this here. Now the graphing calculator unfortunately won't give us these kind of answers. It'll give us the decimal approximation of this answer. So a lot of this here, the 30xs, is a little bit nicer. Questions on this here? And if you do have questions on which form it wants, I will answer that on the test. If this here is the correct form, if we want to keep it in cosine sine form, or if we want to actually convert it back to a plus bi form, I will tell you that. If you need to do one or the other, have both, I will confirm that. I won't tell you if it's the correct version of the answer, if you have the correct numbers, but I will tell you if it's in the correct form. Does that make sense? Questions on these here? We good with 36 with multiplication? 37 is the same thing. It's multiplication, but instead of radians, we have degrees. Our division. We're going to divide our two R values, and the angles this time are going to be subtracted. Do we want to look at 38 or 39? 38. So we're going to divide our two R values, which is going to be 3 over 2. Which is just going to stay 3 over 2 actually. And then we'd have the top number, our theta 1, minus the bottom number. Well, 3/2 is just going to stay 3/2. It doesn't reduce. Our 120 minus 40 is 80. And we get this here. Mode, change it back to degrees. 3/2 cosine of 80 is this here. We'll go 0.26. Plus, you can do the same thing with sine 1.48. I think I went 2 places on the answer key. I do not remember though. But that's it. I have a feeling for the most part on the test, I'm just going to want you to get it to this form. I will specify if needed. Questions on division? I had a feeling exponents were going to be next. C to the n is equal to r to the n times cosine of n theta plus I sine of n theta. So for us here, since we're putting this to the 4th power, we'd have 3 to the 4th times cosine of (60) times 4 plus I sine of 60. This one more time. Times 4. Well, 3 to the 4th is 81. Well, 3 squared is 9. And essentially we're squaring in 9 again. We get 81. Now, inside, 60 times 4 is 240. And I believe that's it. And I think that's as far as the answer key took it to. No. 40. Okay. Well, it looks like I actually took it a step further and just went on and did 81 cosine of 240, which is negative 81 over 2. Then we can do the same thing with sine 81 sine of 240 is negative 81 squared of 3 over 2. So minus 81 squared 3 over 2 I. And again, on the test, I will tell you if you need it in A plus BI form or trig form. Questions on this here? We good with these here? Questions on 42 or 43? Well, if we applied it as it is right now, 2 plus 2I, I wonder. Calculator can do this, but calculator can't do the second one. Because what we would do for this here, we'd find R, which is our A squared plus B squared, which would be 2 squared plus 2 squared. Our 2 squared plus 2 squared, second square root, 2 squared plus 2 squared is 2 square roots of 2. Because what I'm going to do is turn it into trigonometric form, tangent inverse of 2 over 2. So theta is pi over 4 or 45 degrees. Which tells us that we have 2 square roots of 2 times cosine of 45 plus I sine of 45. The main reason I picked 45 degrees for this one here is that no real point in particular, except I remember the graph, or the 30xs is already in degrees, so I just picked degrees. Now at this point here, again, we're applying this still to the 6th power. So what we have is 2 square roots of 2 to the 6th times cosine of 6 times 45 plus I sine of 6 times 45. So A and S, I'm grabbing our 2 square roots of 2, putting it to the 6th power and get 512. Well, 6 times 45 is 270. There is an easy way to do that, because 6 is 2 times 3, yes? What's 45 times 2? Times it by 3. Yeah, because 45 times 2 is 90, which leaves us with 3 as the other part of 6. Well, 3 times 9 is 27. Add the 0 back, we get 270. At this point here, we can do 512 times cosine of 270, which is 0. 12 sine is negative 512, which tells us this is negative 512. That's it. So, I mean, we could try plugging these into the calculator and see what we get. There's a good chance 43 is going to give us a radical if we do it, yeah, a decimal if we do it in the graphing calculator. So for that one there, would have to do the same, possibly do the same thing. You'll just see. And it turns out it won't. Turns out it's just 32. That's fun. Questions on these here? Questions on 44 or 45? Unfortunately, no, this is where we start getting into our z sub k is equal to the nth root of r cosine of theta plus 2 pi n over k. No. One more. Cosine of theta plus 2 pi k over n plus I sine of theta plus 2 pi k over n. Because the reason I remember the distinction is because the n, the bottom of the fraction, never changes. That's how many root or whatever root we're taking. K is the one that's changing. It's the one that goes on top. So for these first two here, we're looking at a square root. So our n for all these is 2. Our k for all three of these here is going to be 0 and 1. We can look at 44 or 45, or 46. I'll let y'all pick. 44. The first thing we need to find is the value of r. R is our a squared plus b squared. In our case, it's going to be 2 squared plus 2 squared, which is going to be the square root of 8. Now, for the most part, we would reduce this down to 2 squareds of 2. I would advise against it because when we start this problem off, especially with z sub 0, we're going to take the nth root of r. Well, in our case, the nth root is going to be a square root, and r is square root of 8. Or instead, we're going to take 2 squareds of 2. It's going to be easier to leave it as square root of 8. Theta is equal to tangent inverse of b over a, which is 2 over 2, which is going to be pi over 4. So inside we're going to have cosine of pi over 4 plus 2 pi times 0 over 2. Don't know why I drew the same. Let's see, plus I sine of pi over 4 plus 2 pi times 0 over 2. Square root of square root of 8 ends up being the 4th root of 8. Square root of 8. Well, the square root of 8 inside is just 8 to the 1/2. The square root on the outside is also just the 1/2. Powers of powers multiply, telling us the square root of the square root of 8 is the same as the 4th root of 8. And unfortunately, that doesn't simplify because, well, 8 cubed, or 2 cubed is 8, so we don't quite have it. If it had been 16, we could have taken the 4th root of 16 and gotten 2. Cosine. So here in the calculator, we can say pi over 4 plus 2 pi times 0 over 2 is pi over 8. Questions on how we got to this here for z sub 0. Now, z sub 1, we'll finish that out in a minute. Cosine, because the square root of 8 is the same as the first, so we don't have to rewrite it. We can just rewrite it as the 4th root of 8. Now, cosine, what goes in here, I'm going to go on and write it out so that we can see it, is pi over 4 plus 2 pi times 1 over 2 plus I sine of pi over 4 plus 2 pi times 1 over 2. So the 4 through debate. But now we just need to type this in. And the only difference from when we typed it in previously and this time is that the 0 became 1, which gives us 9 pi over 8. At this point here, we can plug the whole thing into the calculator. 4th root of 8 cosine of pi over 8. And before I hit enter, I do need to switch it to radians. And well, it doesn't simplify from here. So we're going to just go to the 4th decimal place. We can do the same thing with sine. And again, we're going to go 4 decimal places. 0.6436. So that would be one of our solutions. And again, we can do the same type treatment with z sub 1. And we'd get negative 1.5538 minus 0.6436i. Questions on 44. Now, at this point here, you could have figured out and set z sub 0 up and found the amounts and then just applied it and found the answers for the rest. I would highly suggest at least making sure to write out each one of these in the kind of more simplified form, not the pi over 4 plus 2 pi times 1 over 2. But what you would end up typing into the calculator to get our boxed answers. Because just on the off chance, I'm not saying it would, but on the off chance it might happen that you have the calculator in radians instead of degrees or degrees instead of radians in the wrong form and it gives you the wrong answer for each of the boxes, I will go back and check what you had here to make sure that's right. Because if that's right, I will take it anyways, even though it's just you got the wrong answer in the boxes because it's not so much you did it wrong, it's a calculation error, not your error, especially for these here because these get very tricky, especially with the calculator degrees radians. So I'll be checking, especially for solving when we have to do more than one of them. Questions on this here? You know what? I'm going to say for, what is 50? Okay. For any of these roots, finding the roots, you do not have to, I am not going to make you get them into A plus BI form. I just want to, you just need to get them into, let's get a highlighter. This form here. Don't have to calculate it out, but I do want it in that form. Does that make sense? Questions on 46 through 48? It's funny because, you know. Okay, yeah. So square root we've done. Question on 47 or 48. So are we good with these multiple roots? Because it's the same thing as what we just did for square roots, but instead of having 2, here we're going to have 5. Yes? Because here the n, it's not right in a highlighter. N is 5. K is going to be 0, 1, 2, 3, 4, and that's it. Now for 47 and 48, if you are looking for it in the form that I'm going to be taking on the test, the last page of your review sheet does have it in that form. The main answer sheet has it in decimal form, but the last page does have it in that form there, so that you can see it in both ways. Same thing would be true for square roots, but I didn't add it. I will go back and add that in a little bit. So if we're good with roots, 49 or 50? 50. Since we're solving this here, one of the first things we're going to do is add 243 over to the other side. Now, since the degree of this is 5, we're going to have 5 solutions. Interestingly enough, I mean, we could take the fifth root of 273, 243. 243, don't need 2 fours. And we get this here. But even if we did that, we would still be missing 4 other solutions. Well, what we can do with this here is we're taking the fifth root of this to find the solutions. I'm going to turn 243 into our trigonometric form. R is equal to square root of a squared plus b squared. Well, what's b in this case? 0. So, really we're saying that we have the 243 squared, which is 243. Fifth root. That's why it didn't look right. Fifth root of 243 is 3. So, that makes a little more sense. One of our solutions, if we simplified it out of trigonometric form, would just be the number 3. The rest are going to be imaginary. Now, theta is going to equal tangent inverse of b over a. Okay, right now it's going to be 0. Second tangent inverse of 0 over 243 is 0 radians or 0 degrees, both at the same spot. And that is in the correct quadrant, because if we think of this on the coordinate plane, negative 230, not quadrant, the complex plane, 243 on the complex plane would be 243 on the positive x, but 0 on our bi, which just gives us positive x-axis, which is 0 or 360, 0 or 2 pi, so 0 degrees. Now we can do our nth roots. Well, we can, these are 0. So the nth root, so we have the fifth root of 243. Cosine of 0 plus 2 pi times 0 over 5 plus I sine of 0 plus 2 pi times 0 over 5. Interestingly enough, we already did find the fifth root of 243, which is 3. We found that already. Interestingly enough, well, I need that. We don't need a calculator to do 0 plus 2 pi times 0 over 5, because 2 pi times 0 is 0. If we add 0 to it, we still have 0, and 0 over 5 is 0. So that's our first one. Now really the rest of these are going to be very similar. Except the only thing that's changing is what's inside of cosine and sine. Now I'm going to write this over to the side as a side note, because what we have is 0 plus 2 pi times rk over 5, yes? Where k is going to switch from here 0 to 1, 1 to 2, all the way up to 4. Well, what is 0 plus 2 pi k? Yeah, because 0 plus anything is just whatever the other thing is. So we're just left with 2 pi k over 5, yes? We already found the first one, which means z sub 1 would still have the 3. Now the 2 pi k is what's going to go inside cosine, yes? But the k is not 0 anymore, it is now 'So we have 2 pi over 5 plus I sine of 2 pi over 5. Yes? Z sub 2. The number in front is still 3. But now our value of k is not 1 anymore. It is now 2. 4 pi over 5. Z sub 3. Now we're switching the k value to 3. 6 pi over 5. And lastly, z sub 4. Now we're just switching the value of k from 3 to 4. Eight pi over 5. That's it. Questions on this here? Now the first one, if we did try to convert these over, we don't have to. I'm not going to make you do that. Because if we looked at the first one, 3 cosine of 0 plus I sine of 0, I'll just actually type this into the graphing calculator. What does it matter? Cosine of 0 plus I sine of 0 is 3 cosine. Enter. Because we stopped at 4. Sine. Because once we go past 4, we actually equal whatever the nth root is. We get back to the first solution. If we switch k to 6, we would get the same value of z sub 2. If we did k of 7, k being 7, it'd be 3. 8 would be, let's see here, because 5 would give us the first z sub 0. 6 would be z sub 1. 7 would be z sub 2. 8 would be z sub 3. 9 would be z sub 4. And 10 would get us back to z sub 0. They just end up repeating themselves. That's why we stop for those there. But that's it. Questions on this here? So.